So hello everyone, I Raghavendra Singh welcomes you all in the another lecture. So in this lecture we are going to discuss about Laplace transformation. Laplace transformation. Laplace transformation. Yeah, so basically here are some topics which I am going to discuss. Although I have some topics that does not match from AKTU's levels, so I think I should not discuss that. So let's see. Uh, like start from scratch. So date is 10th of December 2025. I hope this is all visible. So let's discuss about Laplace equation. Laplace equation. Laplace equation. So basically Laplace equation. So Laplace equation is this L for Laplace, okay? Function of t, let me write something that I will discuss, is equal to 0 to infinity limit e to the power minus st f of t to dt. So this is the Laplace equation which we have to remember. This is the only equation which we will use multiple of time, okay? So let's see the proof of it, okay? So like as you can see, here is f of t, here is this t. If I replace this t by k, then here will be also k, right? So let's replace L Laplace of k can be replaced from 0 to infinity e to the power minus st this k dot dt, okay? So now let's solve this integration. So e to the power minus st into k dot dt, as we know that k is the constant, right? So k can be taken as outside. We know that anything inside the integration, if constant, then we can take outside. 0 to infinity e to the power minus st dot dt. Now we have to integrate this simply, okay? Now we have to integrate this. So we know that anything to the power, if we want to integrate anything power of e means Euler equation value we know 2.74, not a finite number, so that value remains same, and upon this coefficient, like, right? So k integration of this will be e to the power minus t as it is, upon this minus s upon minus s, okay? And power will be 0 to infinity, okay? So now simply put the value. So k, let's put the first limit, upper limit first, e to the power minus infinity upon minus s into s, doesn't matter, minus e to the power 0 upon s minus s, okay? So we know e to the power infinity, this will be 0, right? This will be 0. E to the power infinity will be 0, right? And this e to the power 0, sorry, I think s, so e to the power 0, this is e to the power infinity, this will be 0 as we know, and anything to the power 0 always will be 1, right? So k common minus 1 upon minus s, so minus minus can be cancelled. I hope this all visible. Yes. So minus minus cancel means Laplace of k is equal to k upon s. So this is the first formula which we have to remember. Now if here is Laplace of k, if Laplace of 1, then here will be 1 upon s. So this is something how we can remember. I told you the derivation of only one formula. There are so many formulas which we have to remember. If you want to know about derivation, then you can also search online, but I will not discuss that derivation because it will be too lengthy. So I hope you all have understood that what I did here is 0 to infinity, and this, then simply I have did just integration. I just replaced t by k, then simply integration of this, and I have just simply integrated, and here we have Laplace of k is equal to k upon s. Okay, now I'm going to write some formulas to remember. So yes, some formulas to remember in mind. Okay, yes, so basically we have already derived one formula, that is Laplace of k is equal to k upon s, and second formula is Laplace of 1 is equal to 1 upon s, and now main formula start, that is third formula is Laplace of e to the power at. Okay, it means 1 upon s minus a. Okay, and the fourth formula is Laplace of e to the power minus at. So simply here is 1 upon s minus a, and this will be 1 upon s plus a. If you have remembered one formula, then second will be automatically remembered, 1 upon s plus a. Okay, and fifth formula is L upon sine at, Laplace of sine at. So basically a upon s square plus a square. So sixth formula is Laplace of cos at. So this is simply s upon s square plus a square, right? Simply if here is cos, then here will be s. If sine, then here will be a only. And what is a? This a. Okay, now seventh, Laplace of sine h at. Laplace of sine h मतलब hyperbolic. Okay, sine h at. Okay. So hyperbolic means a upon s square minus a square. Okay, if here will be hyperbolic, then this here is change only, and eighth formula will be L cos hyperbolic of at. Cos hyperbolic of at. So here will be s upon s square minus a square. S square minus a square. Just change only, just hyperbolic sine at. Here is only like here sine is changed only, nothing else. Okay, and next formula is, so next formula is which will be 9. It is Laplace of t to the power n. Okay, if this t to the power n, then here will be gamma of Sn plus 1. Okay, or like this is for when power is not finite. Okay, if power is finite, suppose if power is finite, then t to the power n is equal to n factorial upon s n plus 1. Okay, if power is finite, then simply we can do this. If not finite, then we need to like calculate this all. And the next formula is 9th and 10th, that is Laplace of c to the power 80, 1 upon s minus a log c. I hope that we will not use this formula. So let's move on to the next. Let's take now example. There are also some formulas. Now some trigonometric formulas. Some trigonometry formulas. Some trigonometry formulas. So trigonometry formula, you all know in your 12th class, but still we need to revise it. So suppose sine square theta, we know sine square theta is 1 minus cos 2 theta upon 2. Okay, and the next formula is cos square theta is 1 plus cos 2 theta upon 2. Okay, and sine cube theta, it is 1 upon 4 3 sine theta minus sine 3 theta. Sine, now cos cube theta is equal to 1 upon 4 3 cos theta plus cos 3 theta. Okay, yes. Now sine of hyperbolic x is equal to e to the power x minus e to the power minus x upon 2. Okay, and cos of hyperbolic x is equal to e to the power x plus e to the power minus x upon 2. Okay, so these are some formulas which we have to remember while solving the Laplace related questions. So now takes example. Let's take example. So it is Laplace of t square. So basically simple, we know that which formula we will use. We know that here t to the power n, Laplace of t to the power n factorial upon s n plus 1, right? This is the formula. Why I am using this formula? I can also use gamma, but here as you can see it is finite limit. So I can simply write 2 factorial upon s2 plus 1. It will be 2 upon s cube. So I can write Laplace of t square is 2 upon s cube. It's very simple, right? I don't think that here we need to think very much. Simply it's a use of formula. If you know the formula, you can easily solve it. Now let's move on to the next question. Laplace transform of standard function. Laplace transform of standard function. Laplace transform of standard function. So basically Laplace transform of standard functions, let's take the example. First question is find the Laplace transform of 4t square plus sine 3t plus e to the power 2t. Now here as you can see that this all is separated, right? So we will separate each one of each, then after we will do. So Laplace of 4t square plus sine 3t plus e to the power 2t. Okay, I can also write Laplace 4 can be taken as common, Laplace of t square plus Laplace of sine 3t plus Laplace of e to the power 2t. Okay, so now as you know Laplace of t square, which I have find it right now, so 4 into 2 upon s cube, right, plus Laplace of sine 3t. We know that what is formula of sine 80. Let me write the formula also. So we know this sine 80 formula is a upon s square plus a square, right? This is the formula of sine 80. So I can simply put it here. So a, what is here? A is 3. So 3 upon s square plus a square, s square plus a square. A is 3, so 9. Okay, plus what is formula of e to the power anything? So e to the power anything, we know that e to the power anything is 1 upon s minus a. E to the power 80 is 1 upon s minus a, right? So right now I'm writing each and every formula. After solving some questions, I will not write formula, I will solve it directly. So please remember formula and then after do question. So 1 upon s minus a is here 2, so minus 2. Okay, so this is, or I can also write 4 2 is 8 upon s cube plus 3 upon s square plus 9 plus 1 upon s minus 2. So this is the formula, sorry, this is the solution, final answer I can say this. Okay, now let's take the another example. I hope this is all visible. Yes, now takes the another example, that is question number 2. Laplace of cos square, Laplace of cos hyperbolic square 4t. Okay, we have to find this. So how can we solve it? We can solve through yes. So here we can see that cos square 4t, cos square, cos theta square should be cos square theta. We know the formula of cos square theta, right? Cos square theta is 1 plus cos to theta upon 2, 1 plus cos to theta upon 2. This is the formula of cos square theta. So, but here we have to theta, here we have theta 4, right? So here we will put in place of theta 4, so 4 2 is 8, so 8t. So 1 plus cos hyperbolic of 8t upon 2, okay, upon 2. So now I think simply we can solve it. Now 1 by 2 can be taken as common, so Laplace of this 1 by 2 can be taken as common, and Laplace of 1, here will be Laplace of 1 plus Laplace of cos of hyperbolic 8t. Okay, so Laplace of 1, we know what is Laplace of 1, it is 1 by s. It is 1 by s plus Laplace of cos hyperbolic 8t. Let me check the formula which we have discussed already. So what is the formula? Hyperbolic, this cos hyperbolic is s upon s square minus a square. Okay, so s upon s square minus a square means 8 into 8 64, right? So this is the formula, this is okay. So I can write that Laplace of cos square hyperbolic 480, what will be, this will be 1 upon 2 1 upon s plus s upon s square minus 64. Okay, so this is answer. Okay, yes. So now let's take another example or question number 3, that is Laplace of sine 5t. Okay, yes, so sine to the 5t. So how I will solve this one is, we have to find Laplace of sine to the power 5t. So I cannot find it directly, so I can split it in Laplace of sine cube t into sine square t. So if I will combine both of this, then it will be similar. I can write this in this form, right? So now I can use the formula. Like, remember one note which you have to always remember, that uh, whenever we are finding Laplace, it should be in plus or minus form, not in multiplication, okay? Remember this, it should be in plus or minus, so we will convert it in plus or minus. We know that formula of sine cube t. The formula of sine cube t is 3 sine t minus sine 3t, right? This is formula of sine cube t. And sine square t formula is 1 minus cos 2t upon 2. Okay, so I will put here in place of this. So let's put Laplace of 3 sine t minus sine 3t plus sine square t 1 minus cos 2t upon 2. Okay. So yes, so now what can we do is, so 1 by 2, here 1 by 2 I should take common, but how can I take common? Oh yeah, sorry, I forgot. This is here 1 by 4, okay? 1 by 4 3 sin t and minus sin 3t. Okay, so here it is 1 by 4. Okay, 1 by 4. So I can take common 1 by 2. So here will be 1 by 2 only. Oh no, it is in multiplication still, okay? It is in multiplication. Okay, so this is multiplication, so I can take common, like 1 by 4 and 1 by 2 means 1 by 8 I can take common. Okay, 1 by 8 I can take common, and 3 sin t, sorry, Laplace also here will be 3 sin t minus sin 3t into 1 minus cos 2t. Okay, so now I will simply multiply it, this to this to this. Okay, so 1 by 8 Laplace of 3 sin t. I will multiply 3 sin t minus 3 sin t into cos 2t, 3 sin t into cos 2t, 3 sin t into cos 2t minus sin 3t into 1, sin 3t only, sin 3t minus plus sin 3t plus or sin 3t into cos 2t, this is t. Okay, so this is final. Now again we will use formula. I hope if all visible. Now again I will use formula. We know here that this is sine A and sine B. No. Always remember here also, note I can write that we always see a big angle. Okay, we always see a big angle. So we can say this is a big than this. So this will be considered as A. This will be considered as B. So I will use here formula of cos A sin B. I'll use formula here is cos A sin B. Okay. जो कि we know cos A into sin B. Cos A into sin B. So we know the formula of cos A into sin B. Cos A into sin B. We know the formula of cos into sin B, that is cos A into sin B, that is sin A plus B, right? Cos into sin B is sin A plus B. Let me check the formula. Yes. Yes, sin A plus B, and sin A plus B is equal to sin A plus B plus sin A minus B. A minus B. Okay, this is the formula. So I hope this is all visible. Yes. Yes. So let's apply the formula. 1 by 8 Laplace of 3 sin t will be as it is, 3 sin t minus 3 sin t minus, I can take here 3 common because this is sin A and cos sin B and cos A only. So 3 I have taken common. So 3 I have taken common. So so 1 upon 2. So sin A plus B, sorry, formula here also 1 upon 2 sin A plus B and sin A minus B. So 1 upon 2 sin A plus B. Sin A plus B means sin A plus B. A is t, B A is 2t, B is t. So 3t, sin 3t minus, so it is minus, okay, here this is minus, minus sin A minus B, minus sin A minus B. So minus sin A minus B, A is 2 and 2t minus t, so sin t only, okay, sin t. And now let's this 2, sorry, not this 2, minus sin 3t will be as it is, sin 3t will be as it is, this sin, this will be considered as A, this will be considered as sin cos 2t means B. So sin A cos A formula is, sin A cos A formula is 1 by 2 sin A plus B, sin 5t it will be, and plus sin A minus B, sin 3t minus 2t, sin t only, okay. So this is here. So now what can we do is simple 1 by 2 I can take common here 3. Let's check. Now let's arrange it first, like this 3 sin t, and here will be also 3 sin t, this here. So let's arrange it. Let's arrange it systematic, okay. So I can write 1 upon 8. I'm just arranging it and doing just nothing, okay. 3 sin t minus 3 by 2, like this 3 and this 2, so 3 by 2 sin 3t minus sin t minus sin 3t plus 1 by 2 sin 5t plus sin t, okay. So multiplication divide. Now what we will do is for taking common like this and this, what we will do, multiply and divide by 2. Here it is similar. Now here also I will multiply and divide by 2 just to take common, take common and make it more simplified. Okay, so I have taken 2 common, so 1 upon 8 into 2. Remember, this Laplace is still here. So 1 upon 8 into 2, it will be 1 upon 16, right? So 1 upon 16. Here this 1 by 2 has been taken common. So 2 into 3, it will be 6, right? 6 sine t minus I will multiply 3. So 3 sine 3t minus plus plus. So 3 sine t again, 3 sine t. Okay, minus this 1 by 2 has been taken common. So 2 only, 2 sine 3t plus this 1 by 2 also has been taken common. So wait a minute, this is here in multiplication. Okay, this was here in multiplication. So 3 by sine t as it is, and two sine 3t. Let me check. 2 sine 3t, 2 sine 3t. Sine 3t minus 2 sine 3t plus sine 5t plus sine 5t plus sine t. Okay, so here I can see sine 5t plus sine t. So here I can see that this sine t, this, and this 3 sine t and this sine t. Okay, so this is all just similar. Okay, so I can write that 6 sine t plus 3 sine t, 9 sine t plus this 10 sine t. Okay, so 1 upon 16 Laplace again upon 10 sine t minus this sine 3t, here also sine 3t, here 3 sine 3t minus 2 sine 3t means 3 sine t, 3 sine t minus 3 sine t minus 2 sine t, so minus 5 sine t minus 5 sine 3t minus 5 sine 3t. Okay, remember this mark, because if you not focusing on this mark, then it can be a big mistake and your answer can be wrong. Okay, so be careful and solve. So this is sine 3t, and now this is also completed. Now it remains only sine 5t, right? So sine 5t I will put as it is plus sine 5t. Okay, so we have simplified from there to here. So now I can simply take the Laplace, right? I will split Laplace. This is 1 by 16 and Laplace of I can take 10 common. Laplace of sine t only minus Laplace 5 I can, so Laplace of sine 3t only plus Laplace of sine 5t. Okay, Laplace of sine 5t. Now we can simply solve it. I know what is Laplace of sine 80, that is a upon s square plus a square. So 1 upon 16 10 into 1 upon s square plus a square, a is 1, so 1 only, minus 5 into, I know that is a upon s square plus a square, that is 9, plus Laplace of sine 5t, I know 5 upon Laplace s square plus a square, that is 25. Okay, so this is it, s square. Now I can also make it more simplified. This will be 5 into 3 15 and this, so 1 by 16 को अगर हम multiply करें अंदर, so it will be 5 upon 8x square plus 1. I hope you all are getting what I am doing. And 5 3s are 15 upon 16 s square plus 9 s square plus 9 plus 5 upon 16 s square plus 25. I haven't done anything, just I have multiplied 16 inside only. Okay, so this is, I can say, final answer. Okay, so let me recall what I did is, I hope this all is recording. So what I did is, we have to find the Laplace of sin 5t. So what I did, I cannot find directly sin 5t, so I have split it in sin cube t and sin square t. Then I have used the formula of sin cube t and sin square t. Okay, these are the formulas of sin cube t. These are the formulas of sin cube t and sin square t. Okay, so now I have simply put it the formulas only. Then I have taken common. So now here also, as I have noticed that it should be in plus or minus, not in multiplication. Okay, so not in multiplication I have shown here. So we then again here it was showing a multiplication. So what I did is, I simply used the formula, that is cos A and cos B. If you are confusing that why this is not A, why this is not B, so simple, always remember that always big angle. So if this is big, then I will consider it as a or this is B. If I am not doing this, then it will be negative, then again we have to multiply it negative. So it is good that if we solve it before doing that. Okay, so we have done this. Now sin 3t sin, and then again I have used this formula which I have told you, and then simply this formula is used here. Now simply I have arranged it. Now I have to find, now I have to take common so that it can be more simplified. So I have taken common. For taking common, I have to balance the equation. So I have multiplied it 2 and divided it 2. So now simply I have taken 1 by 2 common. So 1 by 8 already outside, then it will be multiplied by 1 by 2, it will be 1 by 16. Okay, now simply what I have to see is the same. So I can see here it is same. So here 10 sin t and 10 sin t and minus 5 sin t sin 5t, and now simply 1 by 16. Now simply I can find the Laplace of this, because this is not in multiplication, it is simple in plus or negative. So I have simply done this. Now simply final answer is this. I hope you all have understood that what I did is. Okay, so let's move on to the next example. So let's discuss the another example. Not example, it is question number 4. So Laplace of cos t, cos 2t, cos 3t. Okay, we have to find Laplace of this one. So remember that this is in multiplication. So firstly what we have to do is solve it through the plus or minus sign only. Okay, so I know here that this is, I can use here formula, it is A, this is B. I can use here formula of cos AB. I can use here formula of cos AB. Use your formula of cos A into cos B is equal to 1 upon 2 cos A plus B plus cos A minus B. Okay, I can use this formula here. So Laplace of 1 upon 2 cos of A plus B is this. A plus B means cos of A plus B, 2t plus t is 3t, cos 3t cos 3t plus cos a minus b plus cos a minus b. A minus b means 2t minus t, it will be t only, okay, into cos 3t. Okay, yes. So now simply what I can do is, now I can take 1 by 2 common, right? So 1 by 2 I can take common, so cos 3t plus cos t into cos 3t. Now here, as you can see, what you can see is, here you can see that still it is multiplication. So what I will do is I will multiply it. Simple, I will open the bracket. So this is Laplace 1 upon 2 Laplace cos 3t into cos 3t, means cos square 3t, right? Cos square 3t plus cos t and cos 3t. So cos t into cos 3t into cos 3t. Okay, I hope you all are getting what I am saying. So now what can I do is cos square 3t and cos. Now I can see again it is also in multiplication, so I will use formula what, because this is considered a, this is b. So simply cos a into cos b. So same formula I will use here too. So 1 upon 2 cos square 3t plus 1 upon 2 cos of a plus b. 3t plus t is 4t. 3t plus t is 4t. Okay, yes. 1 upon t cos 4t plus cos a minus b, means 3t minus t is 2t. Okay, so this 1 by 2 is in whole multiplication. So again what can I do is, so yes, I hope you all can see. So this cos 4t and cos 2t. Now I can see that this is 1 by 4. Oh, now here this is cos square 3t. I cannot find the Laplace directly cos square 3t. So I know the formula, that is cos square theta is equal to 1 minus cos 2 theta upon 2. Okay, I know this formula. So I know what is here in place of theta, it is 3. So 3, so 1 minus cos 6t upon 2. So again here will be 1, I can write here what, I can write here 1 minus cos 6t upon 2. So this 1 by 2, 1 by 2 I can take common, 1 by 2 into 1 by 2, this will be 1 by 4. So I can write cos square 3t, cos square 3t, cos square 3t, cos square 3t plus cos 4t. Okay, this is cos 4t plus cos 2t. Now simply we can solve it, right? Now I can find the Laplace of each one. So 1 by 4 will be outside, and Laplace of this, I can write Laplace of cos square 3t. Sorry, it will be not cos square, it will be cos 60. Sorry, it will be cos 60. Cos 60, okay? So cos 60. Sorry, cos 60 plus Laplace of cos 4t plus Laplace of cos 2t. Okay, so Laplace of cos 60, cos 40 and cos 2t. So what is Laplace? We know cos 80, we know formula of cos 80. Laplace of cos 80, it is nothing but the s upon s square plus a square, right? So 1 upon 4 s upon s square plus a square is 36 plus s upon s square plus a square is 16 plus s upon s square plus 4. Okay. S square plus 16 x square plus 4. What I did is, oh sorry, I did here one mistake, that I forget this one. The cos square theta formula is 1 minus cos 2 theta. Okay, so here will be also 1, right? Here will be 1. So I can write that what is Laplace of 1? You know the Laplace of 1 is 1 upon s. So I can also write here 1 upon s. Sorry, I forgot this one. So this is our final answer. So let me recall, or let me summarize. What I did is, we have to find the Laplace of this one. Okay, so as I have told you property that it should not be in multiplication. It should not be in multiplication. Okay, I have told you already. So I have to change it in plus or negative. So I did that is, I have used simple formula, that is cos A and cos B. You all know the formula cos A and cos B. So I have just used that one. So here this is again a multiplication. So what I did is, I just multiplied it through this. Then again this is cos A and cos B. Again I have used the formula, and now simply I have done this. Now here you all know that how to solve from this to that one. So yeah, I did it. Now let's move on to the next example. Now there are some extra questions which you all can solve. That is question number 5 is Laplace of cos 4t. So what I will do here is, I cannot solve directly cos 4t. So what I will do is cos square t into cos square t. Okay, so what can I do now? Now I can simply use the formula of cos square theta and 1 minus cos 2 theta upon 2. Okay, so I hope that you all can solve through this formula. It's all same and monotonous, so I'm not solving. And next is, I can, so that sine 4t. Okay, this can be also asked. So what can you all do is sine square theta, sine square t into sine square t. So now again you can use the formula of sine square theta. Okay, now simply you will put it, and we have to remember that somehow we have to convert in simple plus or negative form. Okay, yes. Yeah, so now let's move on to the next type of question. So next type of question, what is this? Sin cube t. So yeah, and the next type of question is question number 7, I can say. So question number 7 is Laplace of cos to the power 4t. Laplace of cos to the power 4t. Sorry, not this one. Integration of 0 to the power infinity e to the power minus 2t sine cube t into dt. Okay, this is the formula. So I cannot solve it directly, so what I will do is I will do in step by. So sine cube t, Laplace of sine cube t, this is I cannot solve it directly, so I'll split it. Okay, so no, I will use simple formula, that is simple formula of sine cube t is 1 upon 4 3 sine t minus sine 3t. Okay, so I'll use this simple formula. So now I can solve it. 1 upon 4 can be taken as common. So Laplace of 3 sine t, 3 also outside, 3 sine t means a upon s square plus a plus 1, s square plus 1, because here a is 1, and minus sine 3t means a means 3 upon s square plus a square means 9. Okay, so this is, so here will be a is 1, right? So 1 only. So 3 into 1 upon s square plus 1. So I can take 3 common, right? So 3 upon 4, 1 upon s square plus 1 minus 3 upon s square plus 9. Yes, so yes, so 3 upon s square plus 9. Yeah, so that's it. So now here what is twist is that we have e to the power minus 2t. Okay, but we have integration of 0 to infinity e to the power minus 2t, e to the power minus 2t sine cube t. So here we know anything to the power e to the power minus 2t, this will be considered as a coefficient. So s will be replaced by s minus, जो coefficient है I am considering it as a. So s minus 2, it will be, s will be replaced by s plus 2. Okay, so I'm just replacing s by s plus 2. So 3 by 4, 1 upon s plus 2, s plus 2 square plus 1 minus 3 upon s plus 2 square plus 9. I can also open it and solve it further. Well, it is not necessary. The final answer I am telling you. Oh no. I did a mistake. That here the twist is not to this. Twist is whatever here is, we will replace it. F is equal to that sign, that is s is equal to 2, s minus 2, so f is equal to 2. So I'll put here 2 in place of s. So 3 by 4, I'll put 2, 1 upon 2, 2 is 4 plus 1 minus 3 upon 2, 2 is 4 plus 9. Okay, so 3 upon 4, 1 upon 5 minus 3 upon 13, 3 upon 13. Okay, so 3 upon 13, so 13 into 5 is 65. So 13 minus 5 3 is 15, 5 3 is 15. So minus 2 upon 65 into 3 upon 4. Okay, 3 upon 4, so 2 2 is 4 and 3 upon minus 130. 60. Oh, sorry. Here will be not 5, 13. So 13 5 is 65. Here will be 65. 65 minus 15 is 50. 50 upon 65. This will be 50 upon 65. So this 50 upon 65 into 3 upon 4. 3 upon 4. So you can solve it further. Okay, I'm not going in calculation. Now let's discuss the next topic, that is change of scale property. Change of scale property. Change of scale property. First of all, let me summarize it again. What I did is simply, if there is this type of question, then simply we have to find the we have to see that what can we do. So simply, firstly we can do, that is, find the Laplace of sine cube t. So what I did is I have simply used the formula and I have converted in simple form, that is plus and minus, and simple this to this. Okay, then simply I have put it as is equal to 2, then diff is the value. Now let's discuss the change of scale property. So if Laplace f of t is phi of s, then Laplace of f of at is simply 1 upon a phi of s upon a. This is the we can say concept of change of scale property. We have to remember this. Okay, then 1 upon a phi s minus a. Let's take example. For example, Laplace of f of t is equal to 2s upon s square plus 4. Then find Laplace of f of 2t. Okay, so 1 upon 2 a is equal to here, a is equal to 2, right? So 1 upon 2 into 5 into s upon a, s upon 2 upon s upon 2 square plus 2 plus square is 4. Now simply solve it, 2 to 2 cancel, then 1 upon 2 s upon s square plus 4 plus 4. Okay, yes, so I can also solve it further, s upon s square plus 16. This 4 can be multiplied here, so 2 2 is 4, so 2s upon s square plus 16. Okay, so this is the answer. So I think this video will be very lengthy. Almost it has crossed more than 1 hour. So I'll make part 2 video of Laplace transformation. So thanks for watching. See you in part 2.